Hello there, and welcome back to another day where I have some free time. And in this day's video of unstd-c, well, we'll be debugging the free function again, since it did not do munmap. So let us get started, though I guess I want a reread of this. And let's see. I guess the size should not have the actual size of the data structure itself, the heap chunk type, as well as over here. Since, well, later on, well, that might cause some problems, but we will change our checks if the size is equal to the original size, subtracting the size of the heap chunk data. But let's try running it in GDB now, though I did some changes, so we have to rebuild it. And oh, what's happening? We got to rerun this in GDB and add a breakpoint to free, then run. So next, then print D, then next again, next. Uh-oh, there seems to be a problem over there. So now it's null. And what about the pointer? Well. It is indeed beyond the um the size of the pointer, I would believe. Our libc pointer. So let's try rerunning it. So let's see. The pointer is this, and the pointer for libc memory is that. And let's try adding the size of, no, let's just add a plus 1. And the size of, what is it? The size of the heap chunk type. So surprisingly, it doesn't match up, since I believe that should be it. But no, I guess. So let's try treating this as a character pointer. Now, that I would like to believe is the correct one. So we're doing something wrong in malloc, especially the pointer arithmetic one. Though we have the free section over here. Then we set its size. Then the next one. So we're doing the trimming over here in the malloc function, which we will move later on. But that is not the problem right now. So, which one am I freeing first in hello? I'm freeing A first, and that was allocated first, so it should result in this, I believe. So, where did this address come from? Well, let's rerun that and add a breakpoint to malloc. So here in malloc, let's print out D and the reference D. So it's still null. And then we allocate D. So it's the 7001 that we seen earlier. Okay, go on. Then we can print the original size of this. Oops. That should be put in parentheses. So there's that. Just a quick Python thingy. Convert that. Yeah, that might be weird since this is actually decimal and not hex. So I was wrong in the previous video. Okay. But what about the size? Okay. Then the previous one is null and it's still null. So that is good. And so the next one, then print out the free section. And yeah, that seems not right. So no. What line was this? It's in the free section when we set the +1. So how much is this? Well, let's run Python once again. So it's FVD 170 and oh no, it's 070 and B7000. So gotta copy that, paste it, and subtract it. Yeah, that seems a bit too much, wouldn't you say? So this one is wrong. Though I wonder why it's wrong. Oh, we actually do have to dereference this before adding +1, or else it's gonna add um What is the size of a pointer over here? Though I would like to think it's not that much. Well, not the thousands anyway. So let's quit GDB. Oops, gotta quit that and rerun build. Then let's do this once more. Free and malloc. So, oh, gotta run it first. And let's see the freed section. So print out D and the free. And if we try to add the stuff we did earlier, so +1, and this shall be treated as a character pointer, plus the size of structure, heap, chunk type, and for now that is still wrong, but that should be the return later on, or we can just print out C, and yes it is. So we're now back at main. Well, let's quit GDB for now and rerun strace. And now that's a problem. There is an infinite loop in free, and that may only happen in here or somewhere else. So I guess we do need to rerun GDB, breakout free, and run. So next. Okay, so it did find out our libc memory. Then what is wrong? Oh, it set the free one to null. Then it added it back. So let's try printing C. And the size. Okay. Wait, no, why was that 48? Did I add something to it? Oh, that's a bit wrong. Hmm. Well, let's try looking at the other stuff. So the next pointer. That's a bit concerning. So let's see. Well, it's free. When freeing B, well, let's print out libc memory first. And the size now, still 4063. Though we did try to add the size back to it. So, hmm. Well, let's try going to the next one. So this is where it loops. as there is no next one. And we do actually do, well, we actually need to set this up. So that the next one of the next is null. And that should, well, hopefully remove that problem. And then what else? For here, I would like to believe this is correct, since in malloc we add 1 to C, and to get C back, well, we just subtract 1. So let's just separate this into a new variable, call that f. So that will be the pointer -1. And the next one of C will be f. And here at the return section, well, let's create a label over here, since this should not return early. And the free part, no. We need to go to the return section, though the free section should not be null. Well, not yet anyway. So how would this look like? So A, then B, then the free section. But the chunk data only contains free. So its next one, when we try to free A, then it will be A, then B. Then B would actually point to free in this scenario. So that will maybe perform an infinite loop. So I wonder how this would go. Also, we actually do need to make a check over here. If the previous one is equal to null, then it's libc memory that we need to set to null. Wait, no. How should this go? Should I make this a double pointer again? And actually, make it like this. Same thing goes over here. And here as well. Now, if the previous one is actually null, then before we unmap this memory, we need to set the next one to be the new libc memory. So I guess libc memory can become the next one. So D and next. Oh, I forgot about this one. And if it's not, then the next one will be null, the previous one of the block. Then we can unmap this one. So that should be it, but the size is wrong. So, hmm, I guess another pause is needed, or I should end this here for now. Yeah, I guess I should end this here for now. So thank you for sticking with me this far. And well, I haven't really fixed anything yet. So may I see you on the next one?